Hello, thank you for joining me. I'm Farah Hijazi, and today I'm going to present to you the architecture of flow and decoding urban DNA. Before we dive in, let me thank the PTV group for their Spotlight series and thank Ms. Sherry Kim for her interest in learning about my model. My late father, Nasser Hijazi, established our company in Iran first, and then later in the United States after immigrating here. I can tell you more about it if we have the opportunity to meet. So by now, I think you have a general concept of what this model is going to entail and is about. The hope is that we might be able to start a constructive collaboration on optimizing throughput in all cities and then begin the urban design improvements. Another hope is to collaborate on creating iconic urban landmarks. What I'm showing you here is the Upper West Side of Baltimore at the State Center development, which has a lot of potential for a transit-oriented development. The design here emerged by identifying this potential for a plaza at an upper deck. I'm showing you here the lower deck. All of this area would be not visible, but there's a dip in the grade, and it provides a perfect opportunity to create a couple of decks. I already forwarded you the bigger picture of the entire design in an email, but just wanted to show you that it was because of this diverging diamond concept or maneuver that we were able to come up from an upper kind of a connector, and you would think that you would go around this side, but coming south, we used the diverging diamond maneuver and brought the flow of buses around this side. This is where the vehicles, passenger vehicles, would go to drop people off. And there's a central island there because there's a couple of columns. They could drop off here or park and get service, short-term service, or come here and drop off their passengers. The buses would come through here and drop off passengers. And the design is hinged on escalators that go down to the subway platform and an elevator that it's these two locations here. The elevator that goes down to the platform as well. So this became a bathroom, a waiting area, and this was the lower deck where the buses queue. There's actually enough space to do a linked bus in a couple of these bays, and these would be regional, not only local but regional buses that perhaps go to Virginia and Delaware and so forth. And it was through the clear understanding of the directionality of roadway segments and lanes coming here that this design emerged. And it was just kind of cosmetic work to create the kinds of effect that you want to have at an iconic uh, transit-oriented development here at in Baltimore, Maryland, at this location. So this slide is going to show you a little bit about what the model does at the big picture. I've got some animations coming up shortly about the solutions in this area. Effectively, what the model does is it provides us an opportunity to understand directionality in all of the roadway segments, and then that guides our improvements at intersection scale or intersection level. Here is in this image that I showed you earlier, I didn't include the full picture, but this is the digital architecture language in two-way networks where I guess traffic engineers use this methodology of columns and rows to assign particular movements at every one of these intersections that you see here. I've created an imaginary network of one way. This network happens to have a clockwise rotation at the center block or cell. It's a clockwise cell. So what I'm showing you here is a one-way arterial progression. It's just an abstract or a schematic that I created to show a concept. Now, each of these green lines that I'm showing you, if the network is correctly composed of all of the correct directions on every street, um, technically, these red ones would be the stopped traffic across the blocks, and the green shows progressed arteries. And we've got quadrants. We've got quadrant A and B, which are east-west, and quadrant 1 and 2, which are north-south. Now I'll click and you'll see a short animation. It'll be the red cycle, and then all of these quadrants will reverse direction, and you'll see the blue cycle. Here we go. Red cycle, and now the blue cycle. My red and blue, as I mentioned, are counterclockwise and clockwise flow. So then it occurred to me that A and B are the same, east-west, and 1 and 2 are the same, which are north-south. So I added, in the blue cycle, I made them 1 and 1 and A and A. So in a moment, when we flip these, um, the B and 2 go away and become A and 1. So we have A1 and A1 and 1A and 1A here, and then they swap. And so therefore, that's where we get the idea of a quantum control architecture for the entire network. And this quantum control architecture is controlled from the center to these edges here. In other words, this is this is calculating the speed, the desired speed you want the commuters to travel from this location outward to about this location. And the sizes of the blocks can vary, and the existing traffic signalization could, I suppose, augment how you get to that point.